This laboratory is all about AM modulation. The equations associated with AM modulation are fairly straightforward. The signal EAM of t, or the time division, is the carrier amplitude E sub c plus the modulation function E sub m cosine 2m of t form the amplitude part of the carrier cos omega c of t. If we expand that equation out, we end up with three terms. The three terms are E sub c cos omega c of t, which is the carrier term, the lower sideband term, or LSB term, which is E sub m over 2 cosine omega c minus omega m of t, and the upper sideband E of m over 2 cos omega c plus omega m of t. Alright? Another way to write the equation is in this form, where the carrier, E sub c, times 1 plus m sub a cos omega m of t. If we multiply this all out, we end up with the same equation. M sub a, if you remember, is the carrier, the modulation divided by the carrier. The fundamental difference in these two ways of looking at this equation is in this equation, the original equation, the carrier and modulation E sub c and E sub m terms are independent of one another. In this equation, the modulation term m of a, related m of a cosine omega m of t, has both the carrier and the modulation in the equation right here. That's fundamentally how a signal generator implements the function, as E sub c 1 plus m sub a cos omega m of t. This makes a little difference in the view on the spectrum analyzer. Let's go take a look at the signals.